Hello and welcome to Geomicrosphere. In today's session, we are exploring a powerful tool in spatial analysis known as the spatial interpolation. So, spatial interpolation is a technique used to estimate values at location where no measurement has been taken based on values from known data points nearby. So, it's crucial method in GIS and is widely used in environmental and meteorology agriculture. So, whether we are estimating rainfall in area without weather station or predicting soil property between sample plot or modeling temperature variation across region, we usually use spatial interpolation to help fill the gaps that has been created to get a continuous surface map from scattered data. So we have several methods in the interpolation, but in this video we are going to focus only two, that is the IDW and then the Kriging. So the IDW is the inverse distance weighting, that's the IDW, which assumes that closer points are more similar than those further away. So it's the estimate of known value by taking the weight average by nearby known value, that is the closer points. And then it's simple and then fast. That's the property. It's simple and fast, and the meaning it doesn't rely on statistical models. So it best used and then densely spaced, and then the surface change gradually. So for example, when you are estimating a temperature or elevation across smooth landscape, we can use IDW. That's the best option that we can use. And then when it comes to the Kriging, we have a Kriging is a more advanced and based on spatial statistics. We consider both distance and the spatial relationship between data points, which is known as the spatial autocorrelation. So it's used model called the variogram to understand patterns in data and produce both predicted value and an estimate of uncertainty, which best used into spatial trend with more accurate results. So if you want more accurate results, and then you have to use Kriging. And then if you want less, or should I say less, or if you have data that is densely sparse, you can use the inverse distance weighting. So that's the IDW. That's the difference between the IDW and then the Kriging. So let's go into it. So I have this data here which I downloaded from NASA Power, where I don't know if maybe we can explore that one too, or if we already know. So I have this data here which I downloaded from NASA Power. So as we all can see, I have my data here. So before we can export any Excel or CSV file to ArcGIS Pro, we have to get our latitude and longitude, our year, and then our temperature. So as you can see, I have my temperature, maximum and the minimum temperature here, and then our latitude and longitude, and then the year. So you have to save this data to your file and then export it to ArcGIS Pro. So as you can see, I have 2000, which was the daily temperature, which I downloaded from NASA Power. So leave a comment if you want to know how to download data from NASA Power, so that I will make another video on how to download data from NASA Power. So this is the data I downloaded from NASA Power. So and then I have already saved it on my desktop, so we can just go and then add it to our ArcGIS Pro. So first of all, we go to map, then the map, you click on add data. Okay, so you click on add data. So because we are adding data, Excel data with points, so we have to use XY point data. So when we are using the XY point data, you can see we have add XY point data to map. So we click on it. And then the geoprocessing, the XY point data geoprocessing tool will be open for us to just run it. So let's wait for a few seconds so that okay. So input data is your temperature data that you save on your desktop. So you just have to click on this one, and then you go and then you input your data. Okay, So I have my data here, which I save it as interpolation. Okay, so I have my data here. So as you can see, I have data here. So this is the data that we are going to use. So you just have to click on it. You click on open, then we wait for it to come. As you can see, it's loading here. Okay, so let's wait for a few seconds for the data to load, and we can continue to fill the other forms. We have our output field here where you want to save the data, and then we have our X field, that's the latitude, and then our Y field, longitude. Then we choose our data here, and then we set our coordinate system. So if your coordinate system is different from GSW, GS1984, you can just set your own coordinate system here. So this is the data, you just click on it and then you click OK. So as you can see, it has already here, so automatically the longitude and latitude will select, and then we have to choose here. So because we are using maximum and minimum temperature, we can choose any of them for the Z field. So this one we are choosing the maximum temperature for the Z field. So and then we have our coordinate system, and that's the WGS1984. Then you click on run. Okay, so as you can see, we have our temperature data here, which was taken along the forest and then the coastal region. So as you can see, the data covers some part of Asante region, eastern region, and then western region, and some part of Greater Accra, and then western region. So as we can see, this is our data. So this is the point data. So you can see where the data was taken. So all these places are unknown. So we are coming to predict the value for this place. So we have our data here, and then the next thing we need to do is we need to import our shapefile, which will be used at the latter part of. Okay. So we go to the same place and then we import our shapefile. So I have my shapefile here, so let me use the shapefile. Okay, so we'll be using this later. So this is our data, and then we are going to interpolate it to find the known points of the data. So first thing we need to do is we need to go to our analysis tool. We click on tools, we go to our analysis tool, we click on tools, then you look for spatial analysis tool. So you look into your tools, and then you find your spatial analysis tool. So in your spatial analysis tool, if you scroll down, you can see we have interpolation here. Then you click on the drop down arrow, then you can see we have our IDW, our Kriging, and then we have a lot that is the natural neighborhood spread, and then the top to raster. So this we are using this tool to do the interpolation. So first of all, we are using the Kriging. After the Kriging, then we explore the IDW. So you click on the Kriging, and then so the Kriging, the input feature will be your data, that's the power regional, the temperature. So you just click on it, and then your Z value will be your data. So this one we are using the maximum, so just click on the maximum, and then output field, you can leave it default, or you can just click on it and then store your data. So let me just give it a name. Okay, so let me okay, so you can change, and then when you come to here, that's the semi-variogram, that's the ordinary, then you just leave it default semi-ordinary spherical, and then the output cell size. So the output cell size, you can just you can change it or you can leave it default, and then but you have to let it remain at this decimal place. But you can change this one to, let's say, 7, 6, or any value that you want to change. And then we have our search radius, which need to be a variable, and then number of points. So the number of points, it depends on the number of points that you have on your data. So if you have points ranging from, let's say, 10 to 30, your number of points supposed to be around 10 to 15. So as you can see, my number of points ranging from 10 to 30, so that's why I chose 12. So you can choose any number between that one, and then the output variance of prediction raster, you can just leave it default, and then you click on run. Okay, so as we can see, we have used the known data to predict the unknown data. So as we can see the legend here, we have our legend here, where you can see the lower temperature and then the higher temperature. So all the green parts represent the lower temperature, and then this parts represent the higher temperature. So as we can see, we have our low temperature and then our higher temperature here. So this is how interpolation is done. And then if we want to clip this one to our study area, we just use our study area, and then we just clip it. So you click on your study area, and then you make it whole. So you can see we have the study area, but because the data does not cover the whole study area, you can see we have some part which was not covered by the study area. So this one we can just choose a different study area. So this one, let me just go back and then choose a different study area which we can just exploit here. Okay, so we just go here, and then choose a different study area from here. Okay, so let's just export a new study area which we'll be using. So we can just take out our new study area. So as we can see, the data cover this place, so I can choose any study area from here. So just click on select, then you choose a study area, and then you right click, you go to data, and then you go to export data. So export data, because of this, I will leave the rest of default, or you can change the name to the district that you are using, and then you click on OK. Okay, so as we can see, we have our study area here. So okay, so this is our study area. So we just have to go back to our geoprocessing tool, and then search for clip. Okay, So you search for clip and then you look for clip raster. That's the data management tool. Then you click on it. So when you click on it, input future, you just input your Kriging, and then output future, you will input your study area. This is our study area, and then you check use future class for clipping geometry, and then you check maintain clipping distance, and then you click on run. Okay, so we have our clipping here, and then we can just uncheck this one, and then okay, so this is the study area that we choose. So after getting your data, and then you can choose any study area of your choice. So this is the study area we choose. So we can see our data, our study area fall between a temperature of 32 to 33 to 33.19 from 32.71 to 33.19. That's where our data from. So this is our study area that we choose, and then okay, so this is the study area that we choose. So this is how interpolation are done. So you can see we at first we have only our point data, which we have used Kriging to find the unknown points. So now we have all these places as our temperature, where we can get our value here. So if we want to change this to reduce the class, we can just right click on it, go to symbology. Okay, so as you can see, we have the classes here. We have 9 classes, so we can reduce this to let's reduce this to 5 classes. Okay, and then we have the color here too, so we can also change the color for better visualization. If the color there is not visible to you, so we can just change the color to suit what we are doing. So if you are doing a temperature map, you have to make sure that you have some color that represent temperature, as the red and the blue and those things, and then temperature too, you have to get the color. So we can just click here and then look for a different color. So which color should I choose? Should I use this one? Okay, so we have our data here. So this one, you can see we have our high temperature, our low temperature, and then the medium and then the rest. So this is how Kriging is done. So the next thing is we have to do our IDW and see the differences. So the same process, you go to your analysis or view. You can use analysis or view. You go to tools, then you look for your spatial analysis tool, interpolation, then IDW, or better still, you can search it here, or you can use the search bar here. So this one, you use your IDW. So in that IDW, you just have to input your data. That's our power data, and then we have our latitude here. So this one, you have to change it to either maximum or minimum. So the first one, we use maximum for it. So this one, let's use minimum. Okay, so let's use the maximum. So in the next video, or if you want to try, we can also use the minimum. So let's use the maximum, and then the cell size too is there, and then this is the output field. So this output field, we can also change it to IDW. So you can just make it IDW. Okay, and then we have our power here too, and the number of 0.12, and then we leave all this one default, and then we click on it. So Okay, so this is the results of our IDW, so we have to zoom in. Okay, so as you can see, this is the results of IDW. Okay, so as you are watching the video, you can see the difference between the two, and then the same process, we can just go to our we can go back and then click. Okay, so clip, you use our clip raster, that's the data management tool, and then we just insert our IDW, and then processing extend, we our shift file, then we check this one, and then we check maintain clip extend, then we click on run. Okay, so as we can see, we have our IDW here. Okay, so this is our IDW, and then you right click on it, you go to symbology, then we can change the classes to let's say 5, then the color plate we can change, so let's use different color for the IDW. So let's wait for a few moments for it to run so that we can use the color. Okay, so let's explore the colors and then use different color for IDW. Okay, so let's try this color and see. Okay, so as we can see, we have our IDW and then our Kriging here. So as you can see, we can explore the two. So let me uncheck the rest of the layer, and then okay, so let me uncheck this one. Okay, so this is how interpolation using IDW and then Kriging does. So as we can visualize it here, we have our IDW here, and then we have our Kriging here. I always say Kriging, it's rather Kriging, it's not Kriging. So we have our Kriging here, and then we have our IDW here. So you can visualize it because of network, so the data is loading, so we can just wait for it. So you can see here it's loading, so let's wait for it for a few moments. Okay, so this is our Kriging, and then this is our IDW. Okay, so okay, so this is our Kriging and this is our IDW. So you can see the variation. We use the same values and then the same maximum temperature, but here you can see we have some variation in the data, so you can verify how IDW differ from Kriging. So thank you very much for your attention and your time for watching this video. Please don't forget to subscribe, share and like, and then if you have any comments, please can leave it on the comment section so that I can view it and then address all issue. Thank you very much for your attention once again.